Welcome back. In this video, we will dive into some of the most important terms and concepts you would encounter in Java programming and in the course of this series. I'll try as much as possible to cover all the essentials you would need to write an effective Java code. So grab a cup of coffee, get comfortable, and let's start learning Java together. Let's dive right into it. The first word is keyword, and keywords are reserved words to the computer, and what they do is tell the computer what you want to do or what you want to achieve. I like the term keywords as tools in a toolbox. Each one has its own specific job, and we use them to build and create things. They help us to tell the computer exactly what you want to do, making it possible to write a program. Now, some things you need to understand with keywords is, keyword is case sensitive. They cannot be used as variable names or names of variables. And right here you have the list of the common keywords. For example, you have the abstract, the assert, the boolean, the break, the byte, and so on and so forth. The next word is variables. I would liken variables to a basket or a jar of apples. All right. So for example, we have int apples equals to 5. What this line of code is doing is int here tells the computer that we are making a storage or a basket of whole numbers. Integers are whole numbers, right? And we are labeling the name of that particular storage apples. And then we are storing the number 5. Let's take number 5 as, say, the numbers of apples we have in our storage. All right. So in summary, variables are like label jars that help us to keep track of different things in our programs, just like how we use jars or boxes to organize items. So let us just run this particular code and see what we have back. We should have, I have 5 apples. All right. There you go. I have 5 apples. The next word is primitive data types. All right. We have 8 major primitive data types, which are the integer, the double, boolean, characters, byte, short, long, and float. Let us look at them one by one. Integers. Integers are whole numbers. It's like counting the numbers of apples in a basket. You can have 1 apple, 5 apples, or even 20 apples, but you cannot have half an apple. So let's give an example of what an integer looks like. It's like the previous example I gave of how many apples we have, right, in a basket. So here you just have the int, which is one of the keywords we have, and it's a data type, right? So you have int number of apples equals 5, okay? And then we want to print out the numbers of apples. And then we can have there are plus number of apples in the basket. Okay. All right, let's just print that, and we should have 5 numbers of basket. There are 5 apples in the basket. The next primitive data type is the double. And double is like the number you get when you're pouring, for example, a juice in a glass. You can have a full glass of juice, which is 1.0, or you have a half glass of juice, which is 0.5, or even 0.75 glass of juice. It is, simply put, a number with decimal places. So let's take, for example, all right, let's comment this out, or let's just take it out since we don't need it anymore. So let's take, for example, if you want to write a code for this, like if you want to declare a double, you use the double keyword, and then you give it a variable name just like I did earlier on, so let's just use juice in a glass, for example. So for the variable name, juice in glass, all right, and then equals to, what do we want to store? Here, let's just use 0.75, and then let's print it out. Let's see. So here we can just use a string here. There is juice in a glass of gas. Alright, so let's print this out and see what we have. Oh, there you go. So we have, there is 0.75 of glass of juice. The next data type, or primitive data type, is the boolean. Boolean can either be yes or no, or maybe true or false, right? So in this case, boolean is like a switch, pretty much. Let's just use a switch, for example, a light switch. It can either be on or off. So it only has two choices, a yes or a no, or true or false. For example, let's say we're asking if a child needs ice cream. It's either a yes or a no. So let us just implement what it's going to look like when you're writing a boolean line, for example. So in this case, let's just use the want ice cream, for example. So we have boolean, you want to declare boolean to, and you want to use want ice cream, right? Equals either true or false, so we want to use true, right? And then here we can always print it out. And does the child want ice cream? It's a question, so it's either a yes or a no. Alright, let's print this out. There you go. Does child want ice cream? And then you get a true, which means yes. The next primitive data type is the character. Now, the character is like a single letter of your name, for example. So let's assume your name starts with A, or your name is Alex, for example, right? The letters in those name, or in that name, is pretty much a character. So let's just do an example. Say we have Alex, right? So an example would be, if you want to declare a character type, it will be a char, and then first name, for example, or first name, let's use first name, then equals, and then you want to put in your character type. So if you notice, it is complaining here that, if you see the error here, it says change the variable name type to string. We don't want a string, we want a character. So in this case, you have to change this to a single quote, and then you should be good. Alright? Alright, so this is how to declare character, alright? And then let's print it out. Alright, let's print that. Awesome. The first letter of Alex is A, which is the character we passed in. The next primitive data type is the byte. I would liken a byte to a small box that can only hold a small amount of candy. Now, byte has a limit of minimum negative 128 and a maximum of 127. It is for when you want to store, save small numbers. And how do I know? First of all, how do I know that byte has a minimum or negative 128 and a maximum of 127? We can know that simply by just doing this, right? So we can just get, let's say byte, right? Main value. Let's see what value it is. Equals byte dot main value, right? And then let's get the maximum value. So doing this, we would be able to determine what is the maximum value for byte and the minimum value for byte. But first of all, what did we do here? What I did was just to create a variable of data type byte, which is called min value and also for max value. And then I'm saying, okay, just give me the maximum or the minimum value for a byte and the maximum value for a byte. So let's just print that out. All right. Then let us also print the max value. All right, let's see. Good. So you see that the minimum value that a byte could take is negative 128, and the maximum value it could take is 127. So in summary, when we want to store or save small whole numbers, we go for bytes. The next primitive data type is the short. Short is like a number of pages of a short story book, for example. It is more than a byte, but still a small number. And the maximum you can actually save into a short is 32,767 pages. So let's write a short. Let's just declare a short. So you have a short, and then you have, let's say, pages in a book. All right, equals 300, for example. And then let's just print it out. All right, so we should have, the storybook has the number of pages and pages, right? So let's run that. We should be good. There you go. So the storybook has 300 pages. Simply put. Another primitive data type is the long. And for long is just like, for example, counting all the grains of sand on a big beach, for example. It is for very big numbers that integers cannot hold. All right. So if you want to declare a long data type, you use the long, and then let's say grains of sand, for example. Then equals, let's just use random numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, for example. And you have to end it with an L. All right. Then let's print that out. There are plus grains plus grains of sand on the page. All right, let's print that out. And there we go. We have, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 grains of sand on the dish. Another data type is the float. Right? Now, a float is like a double, but uses less space. It's just like measuring the height in meters and wanting a rough estimate rather than a long precision. If you want to declare a float variable, for example, you start with the float, and then you probably, let's just say height, right? Equals, say, 1.75f, for example, right? Right, then we can print that out, and then the child's height is about height plus meters. Right. All right. Let's run that. There you go. So we have the child's height is about 1.75 meters. Another word you come across in Java is typecasting. What is typecasting? Typecasting is pretty much it's just like turning one thing into another, for example, right? Now, there are two types of typecasting. There is the widening casting, which is automatic, and the narrow casting, which is the manual. But let us understand how casting works. Now, in this data type image I have here, you have the data type of byte, and you have short, you have int, and you have long. Now, if you look at the sizes of them, you have the 8-bit type, and you have the 16-bit type, and the 32-bit type, and also the 42-bit type. Which simply means we all know that 64 is bigger than 32, and 32 is bigger than 16, and 16 is bigger than 8. Which means we can easily put a byte in a short, and a short in an integer, and an integer in a long. Automatically, it would accept it. But what if you then want to turn a long into an integer, or an integer into a short? All right. So that's where the narrow casting comes into play. The narrow casting is pretty much manually trying to make sure that you're able to convert the long into an integer, or an integer into a short. Let us look at the code implementation for that. So for widening cast, right? Let's just say we have an integer type of, let's just name it small cookies, right? Equals 5, right? And then we have a double, right? Of big cookies, right? And then automatically we know that a double would accommodate an integer. So if we do equals small cookie, you would not see an error because it can automatically get this, right? So we can always do a widening cast here and just print out the cookies. Let's just do that. Cookie jar has big cookies. All right. And then if we print that, we should have big cookie jar has 5.0 cookies. And that's because we've turned our integer into a double. Now, what happens when we do something like big cookie? Let's now make big cookie. Let's just bring this here. Equals 5.99, for example, right? This is a double, right? So, and then we want to now convert this big cookie into integer. And then we say is equals to big cookies, right? Then we have an error here because size-wise, a double is bigger than an integer when it comes to size. So how do you handle this kind of scenario? You then do a narrow casting, which is all you need to do is just put a bracket here and type in an integer, and then you're good to go. Now, let us see what we'll get here. Let's see. If you remember from my explanation previously, I said you cannot have a half apple when you're talking about an integer. It's whole numbers. So which means it's going to cut out the 0.99 and give you just the 5. And that is what we have here. All right. So that is typecasting. Another word you come across when you're talking about Java are operators. Now, what are operators? Operators are pretty much the additions, subtractions, multiplications, divisions. And then we also have the modulus. We have the increment we have the decrement. Alright, so addition, as we all know, is just when you had two numbers together, right? So for example, you had two numbers like int, sum, for example, 5 plus 3, right? Sum equals 5 plus 3, for example, right? Now, we already know what that is going to give us. Now, you can also use an addition sign to add strings together, and that is called concatenation. So let's look at what I'm talking about. So for example, I want to add two strings together. Say A, for example, A and then plus B. You can do this. You can also add maybe a number to it, for example. It doesn't really matter. So if you run this, you should have a concatenated number. So you have A5, pretty much. So you can do this with addition, right? You can, in subtraction, we already know what subtraction is. It's just to negate numbers. You pretty much subtract the right operand from the left operand, right? So here you have, say for example, difference equals 5 minus 3. All right. Awesome. So we already know what this is, but you cannot use a subtraction to negate string. It is not possible because they are strings. So you cannot do that. You can only use this for numbers, integer, double, and float, and those likes, right? And the other one again is multiplication, right? Multiplication is not x, so don't make the mistakes. It's the shift and 8. So if you can actually just multiply two numbers together, maybe int, maybe double, it's used for numbers. So int multiplication, for example, equals 5 times 3. So use the asterisk and not the x, right? So that's multiplication. Now, division also is just dividing two operands. You divide the left operand by the right operand. So for example, you have int, let's say coefficient, for example, equals 5 divided by 2, right? And then you should get your answer here. Now, let us print this out. So this will lead us to the next one, which is the modulus. You'll probably be able to understand what that modulus is all about. All right, let's see. And then we want to print out the coefficient, right? So let's print that out and see what we have. We don't need this. Let's just comment that out and then run this code. Let's see. So here, what we have here is 5 over 2, and then we have 2. Now, if you notice, 2 times 2 is 4, which means we have a remainder of 1 that is missing. Now, what modulus does, for modulus, what modulus does is it returns the remainder of a division operation. So, for example, here we have 5 over 2, so let's just copy this, and then we do this, right? Now, in this case, we want the remainder of the modulus. So let's just use the MOD, for example, equals 5 over 2. And let's see what this comes up with, all right? It should come up with the remainder of 5 divided by 2, all right? So let's comment this out since we don't need it. Oh, so, no, sorry. This should be mod and not divided by, all right? All right, there you go. So you have 1 because 5 modulus 2 is equals to 1. When you divide 5 by 2, your remainder will be 1. So that's why you have 1. Okay. The next word is increment. There are two types of increment, the prefix increment and the postfix increment. For the prefix increment, it increments the value before it's being used. And for the postfix increment, it increments the values after it's been used. Now, for the postfix increment, the operand itself is placed after the variable, but the prefix increment, the operand is placed before the variable. So let's look at examples, some code examples for this. So let's look at the prefix increment, for example. So let's assume you have int a equals 5, and then you have int b to be equal to, now we use the operand plus plus a, right? So now let's print this. Let's first print the value of a, and then we print the value of b. Alright? So as I said earlier, the value itself for a would increment before it's being used. So I expect this to be 6 when we run this. Alright, let's run this. Alright, so we have 6. Alright, we don't need this anymore. Now, the postfix increment, let's look at that. So for example, you have int x equals 5, and then you have int y equals x plus plus. Now, if you look at what we did here, the increment or the operand comes before the variable here, but here it comes after the variable, right? So let's print this x. Let's print out our x first. And then let's just print out our y. So in this case, as I said earlier with definition, it increments the value after it's been used. So I expect the output of x to be 6 and y to be 5. All right, let's just try print it out. Let's comment out this. See what we have. All right. Just like the increment, right? We also have the decrement for that, right? The prefix and the postfix decrement. All right. So just like the prefix is, which is pretty much placing the operand before the variable itself. So we have it in decrement. So for example, we have int a, right, equals 5, for example. And then we don't need all this anymore, so let's just take this out. So we don't need them. So we have int a equals 5, and then int b, since we're working with prefix decrement, equals minus a. All right, let's just do that, and let's print that. All right. Let's print our a first, and then let's print our b. Alright, let's print our b and see what we've got. Alright, so in this case, we're working with the prefix decrement, and so what the prefix decrement does, it decrements the value before it's being used. Alright. So that is what we have here. It's before it's being used. All right. Now let us now look at the postfix decrement. All right. So for the postfix decrement, let's just use the same values. All right. But in this case, we're taking the operand and we're putting it after the variable. All right. So let's see. Now, if you noticed here, it's after it's been used, right? So we have int a is equals to 5, and then it's been used here, and then we're printing out how it's been decremented. All right, so it's been used, and then we decrement it here. All right, which makes sense. So now we have our printout of a and b to be 4 and 5. Some other words you come across is a class and a method, right? A class is like a blueprint or a plan for building something, pretty much. I would like to think of a class as a drawing or a design for a toy, for example. It tells you what part of the toy has, and what it can do, but it's not really implementing what the toy can do. So in this case, this is the class, right? So in this class, I could decide to have, say for example, for a toy car, I could decide to have a string of color, right? For example, I could decide to have number of wheels, for example, integer of number of wheels, or number of wheels. Let's do number of wheels, which works, right? Now, this is just what that car has, but it's not telling the car what exactly it needs to do. And that's where a method comes into play. Now, a method is pretty much the instructions, or they perform the operations, they do the manipulation of the data, or define the behavior of that particular object. So in this case, when you already have what the car has, but we now have a method here. And what this method does, again, this is the main method, but let's just explain what this method does. This class, for example, is a public class, which means it is public to everyone, right? Now, this method itself is a public static void main, which means it's a static public class, public method that can be accessed anywhere in the project, and it doesn't return anything. It's void, and the name of the method is main. So if you want to return something, for example, you want to return a string, if you're creating the method, you can always do a return, and then you'll be able to return whatever you want to return, right? So, but in this case, we're just pretty much talking about what a method is. So let's just now implement something that would use the template or the blueprint we have. So in this case, for example, we have the main method, and we want to utilize the blueprint of the class. And we can just come here and just do a main, for example, and then we initialize the main equals to new main, all right? And then since we want to use what the class has, we can just use main dot, say, color, for example, all right? But let's create something in the class itself. Say, let's just create a void, which means it's not going to return anything. Let's just create a drive, for example, all right? And then we know that a car can drive, right? But it's not going to drive here. So it's going to drive in the method itself. So let's go into the method and just say, let's just print out something like the car is driving, for example. It's driving. All right. So we have the car is driving. But look at this. Take a look at this. Let me just comment this out and try to run this code. You would notice that it is not going to implement because, first of all, the class itself cannot implement this code. The work of implementing the code or manipulating the code is the method. So let us utilize this particular code and call it from our method. So we just want to use the dot drive, right? And then we should be able to run this code. Now let's do that and see the car is driving. There you go. So you are able to see the car is driving. And in the same vein, you want to pretty much add another line of code. Say, for example, honk, for example. You have a honk, and then you just print out something, right? And just say beep, beep, for example, right? Beep, beep, right? For example. All right, let's just put an exclamation mark. And then you can also do main dot honk, and then you'll be able to implement the honk, right? Let me pull that up a bit so you can see it. So we're able to implement the honk and the drive, all right? That is that for the class and methods. Another word you come across when you're working with Java are access modifiers, right? Access modifiers are keywords that set visibilities or accessibilities of class, methods, or either maybe variables too, right? So what do I mean? They actually set if you are able to access a particular resource, or a particular variable, or a particular method. Now, one of them is the public, and the public simply means that member or that particular method or that particular variable can be accessed or accessible from other classes, which means it can be accessible in the project. Now, another one is the private, for example, right? the private, if you have, say, for example, private string name, for example, and then you return name, say, for example, name, for example, we don't have name here, so you can always put a parameter and name. What this particular method is saying is that this is a private string method with a name that cannot be accessible outside its class. It can only be accessible in its class, but you cannot use it outside this particular class. I hope that makes sense. All right, the next one is the protected. Now, if you want to declare the protected, you use the word protected, right? So let's just say protected string first name, for example, and then we just want to return. We just want to return first name. All right. Now, what the protected does is the protected modifier allows the method or variable to be accessed within its own class by subclasses and by classes in the same package. If it is not in the same package, it would not. You will not be able to access it outside its own package. And what is a package? Or we talked about this in the previous class. Now, a package, this is a package. But if you create another package, for example, you create another package, this particular protected would not be visible outside this package. I hope that is clear. And then you have the default access modifier. Now, the default access modifier does not have either a private or a protected or a public. All you have is just maybe a void, for example, and then you have, let's just use stop engine, for example. All right, stop engine, and then since you have a stop engine and it's a void, it returns nothing, right? So you can just print out something and then you're good to go, right? So for a default pretty much has no modifiers specified. It is accessible only within its own package. Now, unlike the protected is accessible from the subclass, but the default is not accessible from the subclass. It is only accessible only within its own package. Thank you for joining me today as we explore the basic of Java. I hope I've been able to explain and make you understand these important keywords. If you have any questions, just leave your questions in the comment section. I'll be able to attend to them. Once again, I'm thrilled to be your instructor on this journey towards building excellence. Please subscribe, leave your comment, click the notification button so you can stay updated with our new videos, and most importantly, share with your friends. And see you in the next video.